Hello my dear students, I hope you all are doing good. So students, today we'll discuss chapter 2 of chemistry, that is structure of atom. Okay, so in this chapter today we'll discuss Aufbau principle. Okay, so let us know about this principle. So according to this principle, the electrons in the various subshells are added in the increasing order of this energy. Okay, so Aufbau is German word meaning building up. The building up orbitals means the filling up of orbitals with electrons. Thus, this rule gives us a sequence in which various orbitals are filled up depending upon the relative order of their energies. According to this principle, the electrons in various orbitals are added progressively in the order of increasing energies, starting with the orbital of lowest energy. So every new electron will move into the subshell for which the value of n plus 1 is lowest. If in case for any of the two subshells the value of n plus 1 is same, then the electron will move into the subshell for what the value of n is lowest. Okay, so the increasing order of energies of various orbitals is like 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f. So this is the increasing order of energies. Okay. Now it includes n plus 1 rule, which is as follows. To calculate energy of different subshell, sum of their principal quantum number and azimuthal quantum number like n plus 1 is taken as a scale. Okay. So for example, to find out the energy of 3d and 4s subshell. So subshell we have 3d and 4s. So value n plus 1 for 3d, 3 plus 2 we got 5, and in 4s 4 plus 0 we got 4. So the energy of 4s orbital is less, therefore the electron will enter 4s orbital first. Okay, because 4s the energy of 4s orbital is less. That's why therefore the electron will enter 4s orbital first. In case both the subshells have the same value of n plus 1, so the energy of that shell is lower whose principal quantum number value is less. Okay, so the electron will enter 4p first. Okay, so now next one we are going to learn about Pauli's exclusion principle. Okay, so in this, according to this principle, no two electrons in an atom can have the same set of 4 quantum numbers. Okay, so students, what do you understand by this? No two electrons of an atom can have the same values of all the 4 quantum numbers. For example, the value of 4 quantum numbers for 2 electrons present in 3s orbital is 3s2. Suppose the value of n is 3. So the value of L means the value of principal quantum number is 3. So the value of azimuthal quantum number, that is L, so that is 0, and value of magnetic quantum number 0, and the value of spin quantum number, we denote this spin quantum number by s. So the value of s will be plus 1 by 2. Or in case if the value of principal quantum number is 3, so the value of azimuthal quantum number will 0, and the value of magnetic quantum number will 0. And here we got the value of spin quantum number is minus 1 by 2. Okay, so the three quantum numbers are same for these two electrons, but one quantum number is different, that is spin quantum number. So the value of spin quantum number will different. So which provides the Pauli's exclusion principle. Okay, now from this principle, the number of electrons in a shell or mean energy level can be known because the number of electrons in an orbital is equal to the number of groups of four quantum numbers in different combinations. Okay? Now, so that was all about the Pauli's exclusion principle. Now, moving further, so now we have Hund's rule. Okay? So, in this, according to this rule, okay, so this rule deals with degenerate orbitals having what is degenerate orbitals having similar energy, that is degenerate orbitals. So it states as pairing of electron in the orbitals of a particular subshell like PDF does not take place until all the orbitals of subshell are singly occupied. Okay, so what do you understand by this? It means the electron in the various subshell will get filled with the value maximum multiplicity. The value of maximum multiplicity is attained when all the electrons in subshell are parallel spin. Okay, when it attains maximum multiplicity, it attains when all the electrons in the subshell are parallel spin. Okay, now in any subshell, in all electron shell get pairing singly spin filled and then after pairing shall taken place. Okay, so students, that's all for today. Next portion we'll discuss in our next video. Thank you.